Hey guys, so in this video I am going over the worksheet you should have done in class today with your groups 1-3 study guide and intervention. This is your classwork. So if just looking at the answers and reading the worksheet didn't make enough sense, I'm going to explain it verbally. So all you're supposed to be doing at first is just reading this worksheet. So it's going over end behavior. End behavior is not new. And behavior is what's happening at the ends of your equation or your graph. So it's describing how the function behaves either at the end or what happens to the value of f of x. Remember, that's the same as y, as x increases or decreases without bound, so without an end. So what's new is the idea of limits. So limit is just going to say, like, we don't know exactly what's happening, but as we get closer and closer and closer, this is what should be happening. So we have left end behavior. So that's just looking as we go to the left or as x approaches negative infinity. So you'll notice right here there's a negative infinity. So this whole thing right here is just saying as x approaches negative infinity, f of x, we don't know. So then right end, same idea, but positive infinity. So at the example that it gives you in order to try to model this, it's saying, okay, here we've got a graph, f of x equals x cubed plus 2. And so we want to just describe what's happening to the end behavior. So as x decreases, the y values also appear to be decreasing, so we can write this, the limit as x approaches negative infinity. So as our x values go down, it looks like our y values are also going down. So it's approaching negative infinity. And then we need to confirm the opposite way. So as x approaches positive infinity, it looks like our y values are also approaching positive infinity. Now what I want you guys to do is I would like you guys to make tables for now. So if we look here, we've got 0, 10, 100, 1000, negative 10, negative 100, negative 1000. So right here, we can say as this is as x is approaching infinity, what's happening with the y's? Well, they're just getting bigger and bigger and bigger, so they're also approaching infinity. And then if we look at our x values, as x approaches or is approaching negative infinity, so going to the left, our y values are also going towards negative infinity. Now this isn't always the case. It can approach negative infinity, positive infinity, or a specific value. So in your two examples, and then this is how I would expect you guys to do your homework tonight, you're given this table and, this graph, this function, and I want you guys to use a table. So what you're going to do is you're going to substitute in all of these x values. And let's get in the habit of putting these arrows on the top too. So as x is approaching infinity, what's happening to the y values? So with your calculator, we're going to substitute in 0 in for x, and we get 0. When we substitute in 10, we get negative, I'm going to have to write sideways, negative 10,020. Oops. All right, 1, 0, 0, 0. And then your calculator gives you e, so this is 1 times 10 to the 12th power because it's got so many zeros that your calculator doesn't want to list them all. So if we substitute, or actually let's just look here. So if we just look here, you'll see our y values are getting bigger and bigger, or deeper and deeper into the negatives. So as x is approaching positive infinity, y is approaching negative infinity. So one thing we can say is the limit as x approaches infinity, f of x equals negative infinity. Okay, and then we can do the same thing for the left. You guys fill in this table on your own, but you guys should have seen that this is also going towards negative infinity, and our graph confirms that, but we're not always going to have a graph. We're not always going to have a graphing calculator, so we want to get in the habit of doing it algebraically as well. So as x approaches negative infinity, f of x, well, it looks like it's getting closer to negative infinity as well. So these are going to be our two conclusions, and then this is our table supporting that. So that's all we're doing right now. That's all you have to worry about. Okay? Hopefully this helps.